Hello guys, so today I'll be explaining the chemistry quiz of term 1 week 4. Let's start. Which of the following factors increase the rate of a chemical reaction between a solid and an aqueous solution? So take any solid and any aqueous solution. Aqueous means it's a liquid or water, more specifically water, not a liquid, okay? Now, whenever you see increase the rate of a chemical reaction, you should know that the particles, when they are reacting, they need to have more collisions between them. So let's say we have over here, we have the particles, okay? They need to have more constant and more efficient collisions between them so they can react. So thinking logically, if you increase the volume of the container, so let's say we have, for example, this container, it has 4 particles. And then we have this container, it has a bigger volume, and we have the same 4 particles. Which container is it more likely for the particles to collide more often? Definitely this one. So you should, to increase the rate of the chemical reaction, you should not increase the volume, you should decrease the volume. Okay? So the first one is incorrect. Second of all, increasing the temperature. When you increase the temperature of something, especially the particles, they will have a higher kinetic energy. They will move faster. So if they move faster, they are more likely to collide more efficiently into each other. So increasing the temperature will increase the rate of a chemical reaction. Now, increasing the surface area of solid reactants, this is very true. Why? For example, you have a paper like this, and then you have pieces of paper like this, okay? It is easier to react with something that is in smaller particles, okay? That means they have a bigger surface area. So let me explain it in another way. For example, we have we have an object, okay? Let's say it's like this. This is the object. This object, it's gonna react slower than if it was a bunch of tinier particles of the object, okay? So remember, you should also increase the surface area. The surface area should be what? So the surface area should be larger. Okay, if it is a smaller surface area, or the surface area is decreased, they will not react as efficiently as if it were a bigger surface area. Now, increasing the concentration of aqueous reactant. This is very true, because when you increase the concentration of something, you are adding, basically, okay, memorize that increasing the concentration will increase the reaction rate. Why? Because there are more reactant particles moving together. So the collisions will be more, since there are more particles to move together. What does it mean to increase the concentration? You're going to be adding more particles, okay? So these particles will increase the concentration of the aqueous reactant, okay? And there will be more likely collisions with the other particles, okay? So this is increasing the concentration. And finally, the addition of a catalyst. Now, a catalyst, what does a catalyst do? It speeds up a reaction, okay? But without being consumed within the reaction. So definitely addition of a catalyst will increase the rate of a chemical reaction. Question number 2. Calcium carbonate, CaCO3, and hydrochloric acid, HCl, react as shown below. Which diagrams would be suitable for studying the rate of this reaction? Think of it like this. Anytime you see the balance, use the cotton wool, because with the cotton wool, the gases will be escaping. So then the products which will remain, which is the solid, you can measure the solid or the liquid, you can measure the mass which is the solid and the liquid of the products. So again, anytime you see balance, it has to come with the cotton wool. Why? So the gases can escape. But because we're gonna be measuring the mass of the liquids and the solids. Now, if we need to measure the volume of a gas, okay, we need to use this device. We need to use the syringe to measure the volume. That means there has to be a stopper to stop the gases from escaping. Because if we had a cotton wool, the gases would escape. So what's the point of using this to measure the volume, using the syringe to measure the volume if the gases already escaped from the cotton wool? So again, anytime we see balance, it comes with the cotton wool. And anytime we see the syringe, it comes with the stopper. So the two diagrams suitable for studying the rate of this reaction are 2 and 3. Question number 3. Which of the following best defines chemical kinetics? Okay, it is the study of reaction rates. So please memorize chemical kinetics is the study of reaction rates. Question number 4. Experiments show that the reaction is extremely slow at room temperature. If a reaction is extremely slow, it means one thing, that there are lots of bonds that need to be broken, okay? So the reaction involves the breaking of several bonds and the formation of new bonds. But if they told you that the reaction is extremely fast at room temperature, so they didn't increase the volume, they didn't change anything, it's just like extremely fast, that means there are not too many bonds to be broken. But here they're telling you extremely slow, so it involves the breaking of several bonds and the formation of new bonds. By several bonds, they mean many bonds. Question number 5. How does the increase in concentration of a reactant affect the rate of reaction according to the collision? So, if you increase the concentration of the reactant, the particles and the frequency of collision will increase. So if the frequency of collision increases, then the reaction rate will then increase. So the increase of frequency will increase the reaction rate. Why? Because we increase the concentration. Question number 6. A gas jar flask containing N2 and H2 that react to form NH3 as follows. Now, which of the following increase the rate of the above reaction? Whenever we need to increase the rate, we need to follow on what? Increase the rate, we need to focus on the reactants. So we have the reactants that are N2 and 3H2. So to increase the rate, we can increase either quantity. So you increase the quantity of N2 or the quantity of H2. You increase it, you don't decrease it. And then you can increase the concentration. You can also increase the temperature. You can decrease the volume, okay? And you can increase the pressure. So the more you increase the pressure, the more you decrease the volume, because they are inversely proportional. So the pressure is equal to 1 over V, or is proportional to 1 over V. So if you increase the pressure, the volume is gonna decrease, and if you increase the volume, the pressure is gonna decrease. But for now, to increase the rate, you need to increase the pressure but decrease the volume. You need to increase the temperature and you need to increase the concentration as well. And you can also add a catalyst. Now, also you can increase the surface area. Now, a block of wood burns with oxygen in the air at certain fixed high temperature. How can the rate of the reaction be increased? Okay, you have a block of wood, it burns with oxygen in the air. What we could do, if the block of wood is like this, it will definitely take a long time to burn, okay? So we can shred it, we can grind it so it becomes smaller pieces and it will burn easier. Another thing, air is not only oxygen, it's oxygen plus nitrogen plus sometimes CO2. But so for now, we're gonna take it as oxygen and nitrogen. Okay, so how do we make it burn more? If we replace the air, we replace oxygen and nitrogen by oxygen fully. Okay, and oxygen is O2. Sorry, I forgot. O2 and N2. So how can the rate of reaction be increased? By increasing the surface area. We grind the wood and we cut the block of wood into smaller pieces, and it burns with oxygen, so we replace the air by pure O2. Question number 8. Based on the collision theory, a decrease in temperature of a reaction decreases the rate of a reaction because the number of effective collisions between the particles decreases. Question number 9. This is very important. Nitrogen dioxide can be produced by using the following series of reaction. This is a very, very important question. So what do? We look at the final equation that we need to get. We will take the first reactant. We have NO as a gas, and it is in the reactants, and we have only one NO. So in which equation can you find NO as a gas and a reactant? It is in this equation over here. You found NO. It is a gas, it is a reactant, okay? And its coefficient is 1, so we do not change anything. Next step, we're gonna leave the O2 for later because it is in more than one step, okay? Now we have the NO2. Now we're gonna have the NO2. We have NO2 as a product and its coefficient is 1. So this equation also has NO2 as a product and its coefficient is 1. So we do not change anything. Now if you noticed in these equations, we have O3, and O3 is not found in this equation. So that means we need to get rid of the O3. How do we do it? We need this O3 to change into the product so we can cancel, and they have to be the same coefficient. Why did we choose this one? Because if we changed the position of this one, the whole equation would change, and we are depending on this equation for to get this as a result. So we're gonna change this one, okay? We're gonna multiply it by negative. So anytime you multiply an equation by negative, it will flip. So now it becomes 3O2 gives us 2O3. Okay? Now we have O3 in the reactants and O3 in the products. We can cancel them, but the issue is they don't have the same coefficient. So how do you give them the same coefficient? You multiply by 1/2. So now it's gonna become 3/2O2 gives us 1O3. So now you have O3 in the products and O3 in the reactants, and they both have coefficient of 1. You can cancel them. And we are left with what? We are left with 3/2O2 in the reactants, and we're left with O2 in the products. So what do? We simply subtract 3/2O2 minus 1O2 gives us how much? Then by doing simple math, you're gonna get 3 minus 2/2. Then you are gonna get 1/2O2. So I'm gonna repeat this one more time. Okay, we look at the final equation we need to have. We look first. We have NO. Its coefficient is 1, and it's in the reactants. So here, NO, the coefficient is 1, and it's in the reactants. So we do not change anything. Next, we go to O2. We see we have O2 over here and we have O2 over here. So we're gonna keep it for later, because if it's in two different places, it's gonna be very tricky. So we will leave it for later. And finally, we have the NO2 as a gas in the products, and its coefficient is 1. And we also have it over here. So this equation, we should not change it at all. Otherwise, it will affect the NO and the NO2. Now, let's see. Here we have O3 and O3, but in this equation, we do not have O3. So O3 is the thing we need to get rid of. How do we get rid of it? We said we cannot change this equation. So we need to keep O3 here in the reactants, and its coefficient needs to be 1. So we can change this one. How do we change it? We multiply it by m minus. Why? Because if we multiplied it by a minus, the O3 will become in the products, and then we can cancel the products with the reactants. But we don't stop there. Here the coefficient is 2 and here the coefficient is 1. So how does the 2 become a 1? If you multiply it by 1 over 2. So you're going to multiply this full equation by negative 1 over 2. So we have 3O2. So 3 over 2, O2 will give us 2 over 2, which is 1, O3. Okay, now we can cancel the O3 and the O3. And we're left with what? We're left with 3 over 2 O2 and the 1 O2. And if we solve it even more, we're going to have 3 over 2 O2. Because this one is the reactants and this one is the products, we subtract. So 3 over 2 O2 minus 1 O2. This is not 10, it's 1 O2. Okay? Then you're gonna get from math from before, 3 minus 2 over 2, it will give us then 1 over 2 O2. So the only thing we did was we multiplied this by negative 1 over 2. So if they need the energy, okay, what are we gonna do? We're gonna do minus 427, okay, times minus 1 over 2, okay, plus minus 122. And so then our answer is supposed to be plus 91.5. So our answer is plus 91.5. Question number 10. Calculate the enthalpy change of the reaction. Okay, anytime they tell you bond energy values, what do? Reactants minus products. So anytime you see bond energy, it's reactants minus products. It's the only equation that's reactants minus products. So you're gonna do this minus this. This is 2 times Cl. No, actually no. This one is, we have 1 CC bond, okay, plus 4 CH bond plus 1 Cl bond. So it's gonna be 602 plus 4 times 413, okay, plus the Cl is what? 240. So again, it's gonna be 602 plus 4 times 413 plus 240. So when you do it on the calculator, 1 second. So when we do it, we're gonna have 602 plus 4 times 413 plus 240. We're gonna get 2494. Now for this one over here, we're gonna have 4 times CH bond plus 2 times CCl bond plus 1 CC bond. So it's gonna be 4 times 413 plus 2 times 327 plus 346. So in total, it's gonna be 4 times 413 plus 2 times 327 plus 346. It's gonna be 2652. And we said we do reactants minus products. So 2494 minus 2652. We're gonna get negative 158, but they needed 2 for significant figures. So minus 158.0. Minus 158.0. Now question number 11. In 3 different experiments, equal masses of excess calcium carbonate were reacted with the same volume of hydrochloric acid. In each experiment, one factor affecting the reaction rate was changed. Okie dokie. Now, for these graphs, okay, the only thing that affects the slope and the plateau is if you increase the concentration of the limiting reactant. So if you do anything with like increasing the concentration of the limiting reactant, then both the slope and the plateau will be affected. Okay, it's like okay, let's just explain this and it will be clear. So if we're lowering the temperature, it's not gonna affect the plateau. This is the plateau. Okay, it's gonna in fact affect the slope. So the slope, I'm gonna color it in blue. Oops. This is our slope, okay? Now, the lower temperature will affect only our slope and not our plateau, which is in red. So that means this will decrease. So that means at a lower temperature, B is our curve. Now, we said anytime we play with the concentration, if they told us you higher the concentration, then the slope and the plateau are gonna increase. And if they told you that you lowered the concentration, then the slope and the plateau are gonna decrease. That means what? This is the slope and this is the plateau. No, sorry, this is the slope and this is the plateau. And they both decreased from the initial one, which was A. Okay? I'm assuming it was A, okay? So it's way decreased. It's totally different from this one, a different plateau and a different slope. So what does it mean? That if you play with the concentration of the limiting reactant or with an acid, okay, it's gonna decrease both the slope and the plateau. Now, using lumps rather than powdered calcium carbonate. When you are using lumps, you are increasing the size rather than the powdered. So the surface area is gonna be smaller. Okay, so if the surface area is smaller, then the reaction will decrease. So if the reaction decreases, the slope is gonna be affected, but the plateau is not affected. So if the slope is gonna be decreased, that is definitely the curve B. Now the addition of a catalyst. When you add a catalyst, the rate is gonna increase, but the plateau is gonna stay the same. So A has the steepest slope. That means it definitely had the addition of a catalyst. So as a quick summary, I would like to say, if you increase, or no, let's say we're gonna change instead of increase. So if you change temperature or surface area or if you change the temperature, the surface area, or okay, if you change temperature, surface area, if you put a catalyst, okay, the only thing that is gonna be affected is the slope, not the plateau. So plateau isn't affected. All right? And if you played with the concentration of an acid or limiting reactant, okay, if you played with the concentration or the acid of an acid or a limiting reactant, then both the slope and plateau are affected. So this is to keep in mind. Question number 12. Okay, in general, if the concentration of KiO3 is decreased, so KiO3 solution in SO3 solution are mixed. So if they are mixed, these are the what? Reactants. Okay? If the concentration of KiO3 decreased, so probably KiO3 is the limiting reactant, and definitely if you decrease the concentration of any of the reactants, then the rate of reaction is going to decrease. What does it mean, concentration? It means the quantity, how much there is of something, okay? So if you decreased of how much there is of KiO3, definitely there will be less collisions, so the rate of the reaction will decrease. Question number 13. Same thing but different type of question. If the temperature is decreased, we said if the temperature decreases, then the reaction rate will decrease. Question number 14. Did I put decrease for this one? Yes. Now, the reaction rate of the reaction can be expressed as the quantity of, okay, whenever they're asking you a question like this, you have different ways of responding to this. So you can either take the reactants and you can say the reactants consumed, the amount of reactants consumed, or you can take the products and you can say the products produced. You don't necessarily have to take both. You can take one of them. So you can say, for example, CH4, okay? You can say the reaction rate of the reaction can be expressed as the quantity of CH4 consumed, okay? Or you can take 2O2 and you can put it instead of the CH4. So if you put it instead, so 2O2 instead of the CH4, you're gonna have the quantity of O2 consumed. Same thing for the product. So if you put CO2 or H2O, it's gonna be one of them produced. So the rate of the reaction can be expressed as the quantity of H2O, and of course it has to be produced or consumed per unit time. We shouldn't forget this. Produced or consumed per unit time. This is very important, okay? So H2O produced per unit time, this is an option. O2 consumed per unit of mass, no, we don't use unit of mass and we don't use unit of volume. So the amount of CH4 produced is the CH4 produced or consumed. It is consumed. So the only answer is the amount or the quantity of H2O produced per unit time. Now question number 15. The graph below shows the differences in the rate of reaction at different conditions. So choose the most suitable curve associated with the following changes. If we had a lower temperature, then definitely the rate is gonna decrease. A lower temperature, the rate will decrease, so the slope will decrease. And which one has a decreased slope? Part B. Now, if you have a higher concentration, okay, you're gonna increase the amount of collisions, so the reaction rate will increase. So which one has an increased slope? Because the reaction rate increased, it is A. Now, a greater rate of reaction, definitely something with a greater rate of reaction will have a greater slope or an increased slope, so it is A. A smaller surface area. Now, the collisions will not be as successful if the surface area is smaller. So, definitely the rate will decrease, and B has a decreased slope. So B is for this one. And the addition of a catalyst. The addition of a catalyst will speed up the reaction. So then, it's definitely going to increase the rate, which will increase the slope. So A is the addition of a catalyst. Let's submit and see. Thank you guys for watching. I hope you enjoyed and have a wonderful day.